All right, so you had a chance to implement this, and let's see what you came up with. So we have a bag array. We're trying to make it equal to an array of ints of default bag size on the heap, right? So we wanted to reference that. So bag array is a reference type, right? And we say new to put new data on the heap for reference types, right? This is how we create reference types. And then we can say int because it's going to be an array of integers, right? That's what we're holding in our bag right now. And the size should be default bag size, okay? So hopefully that makes sense. And then we want to set the count, and we're going to say this is a partially filled array, and count tells us how many valid pieces of data are currently in the bag, right? So how many valid things are in the bag. So even though we have a size of 4 things, that's like our capacity, but not all of them are going to be filled with valid things at any one time. And so what we're going to do is we're going to have a count variable keep track of that here, and we're going to set that equal to 0. Okay, so if we want to come to the big board here real quick, and maybe I can make this bigger, okay, and let's kill this. We're on the big board, something, something. Okay, so what we have here is we have the array, and we have our bag array, right? And our bag array is pointing or referencing 4 integers on the heap, okay? And count equals 0, okay? And that's on the stack because count's a primitive int, right? So count equals 0, and bag array is referencing stuff for 4 integers on the heap, okay? But since count equals 0, what we're saying is there's nothing valid in here. There's nothing actually in the bag. So this is just trash. And actually, when you get 4 integers on the heap, there could be all sorts of crap in there. We're not going to look at it. Okay. In fact, Java will get angry if we try to do something with it. Okay. Now, on the other hand, if we come real quickly to a new file that's in here that you probably have in yours too, it's llbag, right? Linked list bag. So we're also going to do this with the linked list implementation. I don't know if I've made the LL-bean joke before already because I did some videos and I had to redo them. So if I haven't made the LL-bean joke, the idea was that ll-bag sounds like LL bean bag, right? You could shorten that to just LL bag, huh? Okay, it's a good joke. Just think about it and you'll get it. So we have this LL bag, this linked list bag, and notice its constructor is really easy. So we have the node, right? And we have this inner class that has data and next, and we can set those things directly. But we don't need to create a node right here. We can just make the head of our LL bag point to null right off the bat. That means it's an empty bag. So it's an empty bag in both cases. It's just a different implementation of an empty bag. So here is the array version of bag, right? And here's the linked list LL bag, right? And right now we have head pointing to null. Okay, so 2 different takes. Now, one more thing before I set you loose on the next part of this is for us to start implementing these, we can start implementing them one by one. But a common strategy is to make these into stubs. What do I mean by stubs? Well, if I hit play here, what we're going to get is we're going to get a thing saying array bag must implement all the inherited abstract methods of bag interface, including this one, right? And if I keep on doing this, it'll keep on bringing up other methods I need to implement, because when I implement bag interface, I'm saying I'm going to implement all these functions. So one thing we can do so that it allows us to test, for example, if we implement insert, is we just put stubs, which are bodiless code so that it thinks we've implemented all of them, or at least we've tried to implement all of them. And so we don't get that error, which will allow us to test this code, okay? So if it's a void, I don't have to return anything. If it's an int or a Boolean, I have to return what that is so that this thing compiles correctly. And this is pretty normal. So a Boolean, I'm gonna return false, okay? And we'll change these. These are just placeholders, right? Obviously, these will be changed as we implement them, but for right now, this is good enough, right? So here, we can actually implement it correctly because the size, the number of things in the bag right now is also going to be called count. So we can just return count. It'll be like a count getter, right? Void empty will empty the bag, so we don't have to do anything with that. Boolean is empty should maybe return false, right? Or true, it doesn't matter. It's just a placeholder, right? Boolean contains target, okay, return false, right? And finally, int get target count tells us how many of a particular target, and we can return 0 for right now. So now, if I hit play, it shouldn't give us any errors in array bag. Let's make sure that's the case. Nope, see now it's screaming at us about LL bag, saying, well, LL bag says it implements bag interface, but I don't see it implementing all of these methods in bag interface. So what we could do actually here is we could just grab all the stubs we've created here and drop it into LL bag interface. And I'll drop it before the node. We know what node entails. It's nothing special. And now this thing can almost compile. There is no count in LL bag, right? LL bag just has head, so we could just return 0 here. And then if we hit play, we've got it running, okay? Now, obviously, it's not doing anything special, but we are here. Okay. So the first thing I want you to do is I want you to implement insert without having to, assume you don't have to resize, okay, the bag. So assume that you don't have to resize the bag, okay? We'll worry about resizing the bag in a second. I just want you to insert the target value into bag array. What does that mean? Well, if someone says, you know, if we have a bag, my bag, okay, and someone says my bag dot insert 15, the way this picture should change, sorry, let me make this big. The way this picture should change is 15 should now be inside this bag, okay? And 2, count, which says the number of things inside the bag, should now be changed to 1, okay? So those are the things you need to do. Keep in mind the index values of this, right, allow you to put variables into specific spots. Hopefully that makes sense. I'll see you next video where we'll talk about resizing. Oh, wait, no I won't. Let's do one more thing, all right? Now in the linked list case, if you want to do insert, which you should do, how would you do that? Well, in the linked list case, if we come back to this picture over here, what we have is we have head pointing to null. I'm going to start using black. It just shows up better. I like colors, but it's getting a little obnoxious. Okay, so we have head is pointing to null. What we need, right, is the first thing we need to do is we need to wrap the 15 into a node, right? And that node then needs to point to the same thing that head is pointing to as its next. Okay, so 1, make a node with 15 as the data. 2, point its next to the same thing head's pointing to. And then the final step will be to have head point to 15. And this is called insert at head. You guys have probably implemented it last time. If you had trouble implementing it, that's how you do it. Okay, so try to implement this and this. Notice that in the LL bag, once we do this, we're done. We're done with insert, because there's no notion of capacity here. You just keep on adding nodes to the beginning, and it should keep on working. Okay. Over here, there is a notion of capacity, which we'll talk about in the next video. All right. So try to do this. We'll implement it in the next video, and then we'll talk about capacity. And I'll try to find the